Okay. Number one's pretty easy. Number two, what can I do with number two? Can I modify one of the equations before I even get started? How though? How would I change the decimals to fractions?
Oh, wait.
Yeah, before we do that though. 3 over what? 10 t equals negative 0.4 r. Oh, sorry. 4 over 10 r plus 1 over 10. Can do that, right? Then what would I do next? Multiply the whole thing by what? 10? Okay? Then I would have to do what? And then to get one of the variables by itself, which one? Now, it works out. Somebody tell me why it works out. Because when I plug this back in for what? When I plug it back in for t, notice what the number is in front of. What's the number in front? 3. So what happens to all my fractions here? What's negative 4/3 times 30? What's it do? It cancels out, doesn't it? You see what I'm getting at? See that? So maybe a little trick that you can use, just try to keep that in the back of your mind. Alright? What about on the second, on number 3? What is something I can do there? Could I do the same thing? Okay, how would I get rid of the fractions here? Huh? No. Just trying to get rid of the fractions, so just multiply by its bottom number. Okay, you got 2 fractions, don't you? Which number do I use? 2 or 4? You need to use the highest one, don't you? Okay, so multiply that by 4. Which gives me what? 1y. It's distribution of the whole thing, right? I'm modifying the whole thing. So it's going to be 4x minus 2. Good. You guys see what I did there? And then what can I do with the 1 here?
Just make it 1.
Just drop it. Yeah, make it y. Okay? So now this will go where? Where would that go? Now, understand something. What do you got in front of the y here? Okay, so it might be helpful to put a 1 in front of that before you place it in for y. So if I rewrite that first equation, it's going to look like that, which means I got to use distribution. Distribute the negative, right? You guys see that? Yes, no? Communicate so I know. Talk to me so I know I can move on. All right? Guys clear on that? That should be enough to help get you started, right? Okay, what about this one? Sum of 2 numbers is what? Okay, what am I going to use for each one of those numbers? What variables? X and y. So my first equation is going to be what? X plus y equals 31. Okay, now the greater number is 5 more than the lesser number. Which one do you want to be the greater number? We'll say that is X is the greater, Y is the lesser than, right? Okay, so the greater number, which is X, is what? Is being what? Equal sign. Okay? Now all I'll do is take that, plug it in for X, solve it, so on and so forth. Just like what we've done, right? Did you get stuck? Confused? What are you confused about? Well, it says what? The greater number is 5 more than the lesser number. We said that the lesser is going to be what? Y, and the greater is going to be what? Okay, so x is the greater. So the greater number, which is x, is going to be what? Okay, 5 more than the lesser. So 5 more than the lesser variable, which is y. Okay. Okay. Everybody know what a complementary angle is? How much? Well, this is Josh. You shook your head like you know how much it is. Anybody know what a complementary angle is? Very good. It's 90 what? Complementary. Write this down. Complementary is 90 degrees. Right? Okay, so A plus B equals what? 90. Okay, and the measure of angle A is 14 less than the measure of angle B. Okay, so A is 14 minus B. That's one of those ones kind of confusing because when you see less than, you automatically assume or think that it's what? Anybody? Anybody? Okay, quality. Okay. Okay, adult tickets to play cost $5 and student tickets cost $4. On Saturday, the adults that paid accounted for 7 more than twice the number of students that paid. The income from ticket sales was $450. How many students paid? All right, first equation, how do I set that up? Adult tickets, how much? Okay, so can I say 5 times A plus what? 4 times S for students. If I were to add those, it's going to equal what? 455. And then on Saturday, adults paid accounted for. So A would equal twice S plus what? 7. 7 more than twice the number of students that pay. So this goes where? Where A, right there. You guys got it? Okay, what does this do? Get it out, right? Okay, let's do some notes. Today's date, 3/23/16. Okay, now, in my opinion, we've learned 2 methods already, right? What was the method? First method. Graphing, right? What are we looking for? Where those 2 lines do what? Intersect, right? What was the second method that we used? Substitution, right? Okay, this method is called elimination by using addition and subtraction. When we used substitution, what was our whole goal? To get down to how many variables? 1. So we could solve for 1 variable, right? What if we had just eliminated one of the variables? Would that work also? Okay, so what we can do is we can take both the equations and combine them, okay, to eliminate one of the variables. Now, I may have to modify one or both of the equations to get what I want, as long as I modify what? The whole equation. Then it still follows my rule of equality. Is everybody clear on that? Okay. You guys got the objective down? Students will solve systems and equations by using elimination and use that method to solve real-world problems involving systems of equations by using elimination. This is the third method. I'm only going to show you three. Okay, graph, substitution, and elimination. Can I use elimination for everything? Yeah. Can I use graphing for everything? Yeah. Can I use substitution for everything? Yeah. Each one has its place, right? When would I graph? When both my equations are what? What form would that need to be in? Slope-intercept, right? When would I use substitution? Well, one of the variables has to be what? By itself. Good. Okay. Elimination I might use when both equations are in what form? Standard. Good. Okay. Has everybody got this? All right. Let's look at a problem. Oh, excellent. Let's go. Okay, elimination. Step one, write the system so the terms are what? They're lined up. Okay? They're like on top of each other. Is everybody clear on that? That's the first thing you need to do is make sure that the coefficients are aligned. Okay, step two, add or subtract the equations using eliminate one variable and then solve the equation. And then substitute back into one of the equations. All right? And solve for the other variable. All right, so now, first step, I got to check for what? Variables are lined up. Are they lined up here? Okay, so just remember like in 4th and 5th grade when you had big numbers that you're trying to multiply or add, what'd you do? You stack them on top of each other, right? Okay, this is kind of the same concept. Draw a line underneath those two equations just like that. Okay, now do I have opposites here? What are my opposites? Negative 3x and 3x. So guess what happens here? They eliminate each other. Okay, combine 4y and negative 6y. What does that give me? Equals 20. Solve for y. Is it 30?
Yeah, that's cool.
Okay, solve for y. Divide by negative 2. Y equals 8. Okay, again, what are we trying to get, guys? We're trying to find what? Where these two lines do what? Intersect at a point, right? So have I found one part of it? So that's negative 15. Now I got to find x. So how do I find x? Very good. Which one do you want to use, Andrew? How many of you would use the top? Well, you guys like smaller or simpler numbers, don't you?
I like being positive. I like positive.
Like positive numbers?
Yeah.
Okay, we got a negative there too, so make sure you take that into consideration, right? Me, I like smaller numbers. Which one has smaller numbers? Top one? So I'm probably going to go ahead and use the top one. Just because it's got smaller numbers and it may go a little faster, okay? Negative 3x, what's 4 times 15? That'd be what?
60.
Yeah, see how quick that is? Okay, so that's negative 60. Add 60 to both sides. Equals 72. Divided by negative 3. X equals what? 26?
24.
Yeah, you're right. Sorry. Again, both your equations are what form, guys? Both these equations are in what form? Standard form. Now, even think back to what we did in 6.2. The whole reason for using substitution is because one of my variables are what? Isolated, right? Could I use elimination on that though? Yeah, all I would have to do is move one of the variables in standard form, right? See what I'm getting at? How many of you like this one? It's pretty easy, isn't it? I told you guys would like this one a lot more. Okay? This is the easier of the three, in my opinion. Each method, like I said, has its place. Alright? Just, it's all personal preference. Now, if they were in, both of them were in slope intercept, could I use elimination on that? Step 1 tells me that they have to be what? Aligned. Well, both of them are in slope intercept form. Are the variables aligned?
Yeah.
Yeah. So it's all about manipulation, right? You guys know the rules of moving, how to move things, correct? Okay. So that's what we've been trying to do. Here's a CYP you may want to write down. Got it? Okay. There's a word problem. Same type of problem. 4 times one number minus 3 times another number is what? How would I write that?
4x minus 3y equals 12.
Okay? Now we are working with what? Systems, so I need another equation, right? Okay, what's my second one?
Times the first number.
Which was, what does that say then?
Okay. Plus
3 times, second number is 6. Find the numbers. This is a number theory. Remember number theory that we did? Like find 3 consecutive numbers. Remember that? It's kind of like that. Okay, can I eliminate one of the variables? The what? Eliminate the y, right? Are they lined up?
Yes.
Okay, so draw your line. 4x combined with 2x is 1/8 equals divided by 6. X equals 3. So one. Now, understand this problem a little bit. Would I put this would I put my answer in order pair format? No, not necessarily. It's not asking me where they intersect. What is it? It's just asking me what the two numbers are, right? So I don't necessarily need to put it in order pair format. Is that, you guys clear on that? Okay. So I know that X is going to be 3. We need to find the other number, which is going to be what? Which one do you want to use? Second one? Okay, so 2 times 3 plus 3y equals 6. 6 plus 3y. Subtract 6. Y equals what? How's that working for you? Just like that?
I like it better than the last one.
Yeah, their substitution is pretty involved, but this one, speed-wise, a lot faster. I think it's a lot easier to keep all your information. The problem you run into is, what if you don't have opposites?
Oh, yeah.
What if you don't have opposites?
You just.
Can you make an opposite?
Yeah.
How do you make an opposite? Multiplying the whole equation by what? Big my. So I can change it, right? That's what you're gonna have to get used to, okay? You're gonna have to modify, you may have to modify one or the other, or you may even have to modify both of them. Okay? We'll get into some of those later though. There's another CYP.
It's a really, really, really smart idea.
Guys got it? Anybody need more time? Okay. Next. Okay. So here's one I was talking about. When you notice here, my variables lined up, do I have opposites? I don't have opposites, do I? Okay, look at your coefficients though. What is a coefficient? Number in front of the variable, right? Look at your coefficients. Can I modify one of the equations to get what I want? Which one? The first one or the second one? Huh? I like the second one. I'm going to multiply that by -1. Now, it brings up a good point. Does it matter? It does not matter. Okay? I can multiply the top one by what? -1. It's not going to matter, guys. Okay? I'm just going to do the bottom one. I'm going to go ahead and modify it to what? Now, I'm going to just do it like right underneath it. That's plus 3y equals -18. Then I put my line underneath there. Now, just understand that I'm not using this one anymore, am I? I'm combining this one and this one. So what happens to the x's? Cancel each other out. 2y and 3y is, and then that's going to be 20 divided by 5, y equals 4. Okay, which one do you want to plug it back into? Top one? 4x plus 2 times 4 equals 28. So 4x plus 8 equals 28. Subtract 8. 4x equals 20 divided by 4. X equals 5. Now this is a system of equations, so well, how do I put my answer? What?
That should be 10, not 20, because it's 28 minus 18.
Yeah.
Oh, my bad.
Okay, I was
That's what I was too. I was like, what?
I just messed up my forward.
That's okay. My bad.
It would be 10,
If you can have
and then you divide by.
Yeah. So 28 minus 18. So y equals 2, not 4.
What? Format.
On the very top, we'll be 28 minus 18 equals 10. On the third.
Oh, that's it. Okay. You should be okay. Understand?
Yeah.
That'd be 2, wouldn't it?
Yeah.
Okay, so. Who pick up? Am I good now? Okay. Subtract 4. 4x equals 24 divided by 4, x equals 6. Okay, now, how do I put my answer? How do I show it? Do I need to show it in order pair format? Yes. On this one, yes. Did you get all that, Justice? You look out of it today. You out of it? Too much. The sun get to you yesterday? It was horrible, wasn't it? You don't try to play baseball in it. It's a challenge. CYP. Got it? Everybody need more time? You know something that you can do on your sticky notes too? Like when I show how to work on a problem and they give you the CYP, put it next to the example that they just worked. Would be a pretty good idea too. Okay, real world, example 4. Got that?
Yes.
Okay. Hardware store earned $956.50 from renting ladders and power tools last week. They charged 36 days for the ladders and 85 days, so it's a rental fee, right? To get charged per day, right? Okay, so my first equation would be what?
36 plus 85 y equals 956.
Okay, and this week it's going to be what? Okay, which one do I need to modify here? The bottom one, got, I don't know if I should show you this. You guys watching? I know I'm gonna modify the bottom one, right? How would I modify it? So if I do that, it's just gonna change that to a negative. It's gonna change that to a negative and change that to a negative. You guys see how I did that? Okay. Alright, so eliminate 15y equals 0, 5. If it's 9 from 16, that'll be 7. Divide by 15. Y equals
825.
Okay, now, is that for the ladders or is that for the power tools? This is be what? Power tools. So for me to rent a power tool, it's gonna cost $8.50 a day, right? Okay, let's find X now. Find out for ladders. 36 times 850 plus 85y. 956.50. What's 36 times 8.5? Let's do that on the calculator real quick.
PLC.
368.
No way. PLC. You got on. That's it.
306 plus 85y. Okay, subtract 306. 650. 0.50.
Yeah, put it in for X. Yeah, Y equals 8.5.
Why don't you guys stop me?
I
Earlier.
didn't realize anything.
Earlier. My bad. Yeah. I've got 1,000 things in my mind right now. Sorry about that. That's a 5. So 722. Okay, so 36x gonna equal what? Minus 722. 234. Then divide by, so $6.50. For what? Ladders. Okay? Got it? I may put that one on the CYP. That's a good one. Oh, there's one. How many scenarios you got here? And what are they? Got two people, right? Okay, they got a morning walk and then afternoon walk, right? So those are your two equations, right? Okay. Because both of them combined in the morning, they did, Marcus did 11 miles and Lisa did 13, which raised 523.50. Now after lunch, they did the same thing, but Marcus did 14 and Lisa did 13 again. But in the afternoon, they raised 586.50. Right? Those are your two equations, right? Got it? I'm tired. Sum of two numbers is what? This is a EOI. Might see this on the EOI or something similar to it, and how it relates to what we just went over. Sum of two, this is kind of a number theory problem too. Sum of two numbers, so how would I write that? Five times first number, x, minus the second number. Yeah. Do I have opposites? Which one? So that would be now, which one of these would you use? I'd use the top one. Okay, 6 plus y equals 24. So y equals, no, we're not dividing. Now you're subtracting. So that'd be what? Right? Is my math right? Okay. Now, do I need to put this in order pair format? Yeah. It's just, they just want to know the numbers, right? So I have to put it, I'm not trying to find where they intersect. I just need to know the two numbers. That's a good number theory problem. Let's skip that one. Then we're gonna run out of time. Go back, put your math drink in the box, check your master box. What do you think about me? You guys good on your fair check? Yeah, I don't think I. Do you have opposites on the first one?
Yes.
Which one? Y's. What about this one? X is good. Okay, what about this one? Do you have opposites?
On that one, but not on the same.
You got opposites, but the problem is what? Your coefficient is wrong. Okay, so which one is my coefficient the same? On the y's, but I got a negative and a negative, so I need to change. You guys remember how to do that, right? There you go. If you get real good, just change the signs. You know what I'm saying? Like which one? So do the second one or the first one?
You just put 2x plus y.
Plus,
1/4.
plus, plus. Okay? I can change, if I need to change at least one part of the equation, I gotta change all of it because of rules of equality, right? Okay, what about on the next one? Which one, the first one or the bottom one? negative, negative, negative. Got it? All right. I think I did a good job, right?
Thanks, Angelina.
Really quick, like,